Today, we collected some data to reach a claim that the initial velocity of the dart is 10 meters per second. And now we will collect other data to corroborate or validate that conclusion. My goal is to fire this projectile through a photogate timer, and if I know the length of the dart that breaks the photoplane or the photogate, then I should be able to calculate its velocity. So the first thing I'll do is measure the length of this dart. And everybody can clearly see there, or maybe you can't. I'll take my word for it. That's 7.5 centimeters. 7.5 centimeters. Here you can perhaps see the photogate. You can see the timer, and I have my projectile launcher right here. All right. So how long does it take a dart that is 7.5 centimeters long to break this photogate? 0 seconds. It's traveled infinitely fast. So we violated a fundamental law of physics that we can't break the speed of light. Rather than entertaining such an absurd idea for too long, we'll run another trial of the experiment. Okay, so that's working okay. Check it again. Get you guys a good view here. Actually, will be a really good view. Don't worry, class. I've got a face shield on. .0043 seconds. Meet me over here at the chalkboard. Okay, good. Run with chalk. We have a velocity, which is a displacement divided by a time, which was a displacement of 7.5 centimeters, so 0.075 meters per 0.0043 seconds. .17 meters per second. All right. And so according to this data, the dart is traveling much faster than the claim that we can reach from the ballistic pendulum experiment conducted this morning. And you could maybe say, Well, there's plenty of reasons that we could account for why this may be faster. Like, for example, if the entire length of the dart did not break the photo gate, but only some fraction of this distance did, then that would sort of inflate the velocity, because this time isn't sort of an accurate time, you know, if that entire length didn't break the photo gate. But also we could say that maybe there were some energy losses in the ballistic pendulum. So this assumption here, that the potential energy is equal to the kinetic energy, we are assuming that all of the kinetic energy that's delivered into this pendulum dart system is indeed converted into potential energy due to gravity. And perhaps that's not a valid assumption. Maybe there's some other energy losses that aren't just negligible, but are appreciable. And that's why this may be an accurate reflection of the velocity. And we're under sort of calculating it with the other lab work. So I leave it to you to kind of include any of that in your analysis for the reasoning statement, for your claim evidence reasoning. You know, you can make a claim of 17 if you like this conclusion, make a claim of 10 if you like this one. You could average them and say, oh, I kind of think that those are both good ways. And, you know, it's probably somewhere in between those two. That's perfectly reasonable, right? But it's up to you. Just write it up in your CER and have it on my desk, figuratively speaking, you know, in my email inbox Friday by noon. Till next time.